Today's our topic of discussion is coordinate system, in which we will discuss today about rectangular coordinate system. And the rectangular coordinate system will contains three coordinates x, y, and z. Before going to the three-dimensional rectangular coordinate system, first we will see what is two-dimensional rectangular system, which has only two coordinates called x and y. Consider a coordinate system. This is one plane, that is xy plane, right? If I take some point P here, and this is called origin, this is we call origin. This is the main important thing for any coordinate system is the origin. Never underestimate the origin. Origin has the complete power. Origin's coordinate systems coordinates are 0 and 0, right? And whatever the coordinate we represent it with respect to origin. And if I want to reach this point, what I do is I travel for some distance in x, and I'll travel for another distance in y, I'll reach that point. And if I take any point on this particular plane, I should be able to reach, right? Suppose if I take this point, if I travel in x direction for some distance and y direction for some other distance, I'll reach this point. That is the importance of xy. Now we'll see. We'll extend it to the three dimension. I am reaching in two dimensions this point. Suppose you are seeing this lecture, and if I want to reach your eye from this particular point, then it's not possible for me to reach your eye by traveling in x direction or in y direction. I should travel in other direction which is coming out of the plane of the paper, right? That is a normal to the plane of the paper, which is what we describe as another axis, which is called z axis. That's we go into three-dimensional view from two dimension. Let's see it more clearly. This is three-dimensional coordinate system, and this red line is called x-axis, and this green line is called y-axis, and this blue line is called z-axis. In representing the axis, it is not random that we can accommodate any line to x, any line to y, any line to z, but they must be interlinked. We follow one system called right-handed system. That is, fold your four fingers except thumb of your right hand, and thumb will point the z direction when these folded fingers direction is from x to y. That is, it should follow a right handed. If you write x y z in a row, and x is z, x y to z, that is, if you fold your fingers from x to y, the thumb should represent z. If you fold your fingers from z to x, thumb should represent y. If you fold your fingers from y to z, thumb should represent x. This is what the convention of right-handed system. It has three planes named xz plane, xy plane, and yz plane. Now we'll see what is xz plane. If xz plane is y equal to 0 is called xz plane. That is, if I suppress the y axis, and whatever I am seeing is called xz plane. See, I have suppressed that green line. That is, I have suppressed the y axis. So this is called x and z plane. And if I suppress this red line, that is, if I suppress the x axis, which gives me yz plane. We have suppressed the red axis, and the two-dimensional plane which I am saying is y and z plane. And similarly, if I suppress the z, I will see the xy, which we had seen, that is two-dimensional view. Now, suppose if I draw a line like this, I am drawing a line like this, see here, and this line is distributed between this blue line and red line. That is, red line is x-axis and blue line is z-axis, and it has no relation with the y-axis, right? It is represented completely in two dimension. It has nothing to do with z-axis. That is, we can represent two dimension in three-dimensional axis also. Now we will see the same thing in three dimension. Now see here, if I take this peak point, this particular point, it has all the three dimensions. That is, we can never represent this particular point using only two coordinates. See, if I travel for some distance in x, if I travel for some distance in y, and I should travel for some distance z to reach this point. See it more clearly, right? It has some height. It has height. See, it has height. It has height. This particular figure. It has some height. It can only be represented in three-dimensional view. And we now introduce a special concept called projection. Projection is nothing but representing a three-dimensional thing in two dimension. That is suppressing one axis, and I will see what it looks in two dimension. I'll just use a glimpse of it. I don't go into the mathematical derivations and all, but I'll just give the concept of it. See this area, that is this looking like this. It's not a triangle, it's not a closed thing, but just like a sawtooth. And this is what we see in three dimension, right? What can we see if I suppress it in y direction? That is, if I suppress this green line, and what we see, that is, this is what we see in these two axes. That is the projection of this particular figure on z and x axis. That is zx plane, xz plane, zx plane, whatever, anything is correct. This is got the projection of the complete figure on z and x, and we'll suppress x. This is what we see. We suppress x, and this is the projection of it on y and z plane. And it may be a little bit confusing for you in seeing the projections for this particular random figures. Now we will consider some conic sections which we are familiar with, and we will see the projections. Now we will see the projection concept little bit clearly. Here I am considering a cylinder. You are able to see the cylinder, right? It's a three dimension. It is distributed three dimensionally. See here. And what if I see it in only x and z direction? That is, if I suppress the y axis, right? I am suppressing the y axis. See, this is what we see in two dimension. And if we suppress it in z direction, say this, that is, cylinder appears to be a circle if I suppress the z direction. Then what you have noticed is, if I place a cylinder and if I see it from the top, that is, I am not considering its height, something like that, you will see the circle here. That is what the projection of the cylinder on xy plane. Thank you. If you like the video, please subscribe.